Today's lesson is just like yesterday about unit rates, but now we're looking at fractions. Today's aim is that students will be able to determine unit rate and use unit rate to compare two quantities, including fractions. Some key vocabulary. 1. A rate is a ratio between measurements with different units. A unit rate is a ratio between measurements with different units when the second value equals 1. As we talked about yesterday. A constant rate of proportionality means that the quantities increase or decrease at the same rate. Constant means same. Key points. Steps to find a unit rate. This is the same as yesterday. Step 1, rewrite the information in the question as number in units per number in units. Number 2, rewrite that statement as a division problem. Number 3, to find the unit rate, divide the numerator, that's the value before per, by the denominator, the value after per. Remember, to divide fractions, flip the second fraction and multiply. Write your answer using units. So let's look at the first example. Mr. Hamlin was making blueberry muffins. The recipe called for 3/4 a cup of sugar and 1/8 cup of butter. However, he accidentally poured in a whole cup, so that's 1 whole cup of butter into the mixing bowl. In order for the recipe to be proportionally correct, how many cups of sugar would he need to use? First step, I always cube my question. I'm going to circle my numbers and the units that go with them. 3 cups of sugar, 1/8 the cup of butter. Even though I don't see this number, I know that a whole cup of butter is just going to be 1 cup of butter. So I'm going to circle that as well. Then I'm going to underline some key words. I want it to be proportionally correct. Now I'm going to box my question, how many cups of sugar? And I'm going to eliminate unnecessary information. Well, we don't really care what he was making, so I'll cross that off. Now I'm ready to follow my 4 steps. Step 1, I'm going to rewrite the information in the problem using the original recipe with per. So my recipe says that I need 3/4 a cup of sugar and 1/8 cup of butter. So I'm going to write that as 3/4 cup of sugar, C stands for cups, per 1/8 cup of butter. Now I know Mr. Hamlin actually put in a whole 1 cup of butter, not 1/8, he put in 1. So I'm going to need to find the unit rate. So step 2, I'm going to write this as a division problem. So I'm going to write 3/4 divided by 1/8, so I can find my unit rate. Now I know when I divide fractions, I flip the second fraction and multiply, so I'm going to change this to 3/4 times, I find the multiplicative reciprocal. So this is 8 over 1. So now I have 3/4 times 8 over 1, and I have 3 times 8 multiplied straight across is 24, and 4 times 1 is 4. Now I'm ready to simplify. 24 divided by 4 gives me 6. Now I write my answer, so I did my division. I'm on step 4. I write my answer using units. So I write the 6 cups of sugar per, and I know that I'm going to have now 1 cup of butter because I found my unit rate. The second value is always 1. Now I look back at my question. Mr. Hamlin poured in a whole 1 cup of butter. So 1 cup of butter, well, he needs 6 cups of sugar. So I'm going to write Mr. Hamlin needs to use 6 cups of sugar. And I'm going to box my final answer. Let's look at example number 2. While the muffins were baking, Mr. Hamlin decides to paint his living room orange. According to Home Depot, he should use 1/3 a cup of red paint for every 2/5 cup of yellow paint. However, Mr. Hamlin decides to use 1/2 cup of red paint and 4/5 cup of yellow paint. Will his mixture turn out the same shade of orange? If not, will it be more red or more yellow than the Home Depot version? So first thing I always do is cube my question. I'm going to circle all my numbers and the units that go with them. 1/3 cup of red paint, 2/5 cup of yellow paint, 1/2 cup of red, and 4/5 cup of yellow paint. I'm going to underline keywords. I see every, that makes me think I'm going to need to find a unit rate. And I'm looking for the same shade. So I'm thinking about having a constant rate of proportionality, so they're the same. Now, I'm ready to eliminate unnecessary information. So I'm going to eliminate this first line. We don't really care what he was doing. And we're ready to figure this out. Now, we actually have 4 pieces of information. So we're going to need to find 2 unit rates and see if they're the same, because we want to have the same proportionality, the same shade of orange. So let's start with the Home Depot version. We're going to go through each of my steps. Step 1, I'm going to write the same information using per. So I have 1/3 cup, C stands for cup, of red paint per 2/5 cup of yellow. Okay, next step I'm going to write as a division problem. 1/3 divided by 2/5. Step 3, I know I need to, in order to divide fractions, I need to flip the second fraction and multiply. So I have 1/3 times, flip it, 5/2. Multiply straight across. 1 times 5 is 5. 3 times 2 is 6. Rewrite. So I have 5/6 cup of red per, now I know I have 1 because I found a unit rate, 1 cup of yellow. So that's what Home Depot says. Let's see what Mr. Hamlin actually did. Mr. Hamlin decided that he wanted to use 1/2 cup of red and 4/5 cup of yellow. So 1/2 cup of red per 4/5 cup of yellow. Write it as a division problem. 1/2 divided by 4/5. Make sure I put them in the same order. Red, yellow, red, yellow. Good. Now I'm ready to flip and multiply. 1/2 times 5/4, multiply straight across. 1 times 5 is 5. 2 times 4 is 8. Rewrite. 5/8 cup of red per 1 cup yellow. Now we need to compare them. Are they the same? Well, the Home Depot version said to use 5/6 cup of red. Hamlin used 5/8 cup of red. So they're not the same. So I'm going to say no. The mixture will not be the same shade of red. Oh, of orange. So step 1, no, it will not be the same shade of orange. Then it asked, will it be more red or more yellow? Well, we're thinking about 5/8 and 5/6. We know those are not equivalent fractions. They're not the same, so it's not going to be the same shade. Which one is bigger? Is 5/6 bigger or 5/8? So the way we can think about that is if you have a whole thing and you divide it into 6 parts, 1, 2, 3, 4, 5, oops, I'm going to make those a little bit smaller, 6, versus if you divide it into 8 parts. Are 5 of these parts going to be more than 5 of the smaller parts? Yes. So the Home Depot version is going to be more red. So Mr. Hamlin's version is going to be more yellow because he didn't put in as much red as the Home Depot version. So I'm going to say Mr. Hamlin's walls will be more yellow. Than the Home Depot version. Because I know that 5/8 is smaller than 5/6, so he didn't put in as much red. He put in more yellow than he put in red. Now it's time for you to practice.